announcement today. Scientists at the Lawrence Livermore National Laboratory's National Ignition Facility made history by successfully producing a nuclear fusion reaction that yielded a net energy gain. A progress U.S. officials hailed as a landmark achievement, and a milestone for a clean energy future. What is nuclear fusion and why is it important? Nuclear fusion is a man-made process that mimics the way the sun is powered. Nuclear fusion occurs when two or more atoms fuse into a larger one. A process that generates a huge amount of energy in the form of heat. Scientists around the world have been studying nuclear fusion for decades, hoping to recreate it with a new source that provides unlimited, carbon-free energy, without the nuclear waste generated by today's nuclear reactors. Fusion projects mainly use deuterium and tritium, both isotopes of hydrogen. The deuterium produced by mixing a cup of water with a little tritium can power a home for a year. Tritium is much rarer and more difficult to obtain, although it can be made synthetically. Why is it more effective than charcoal? Unlike coal, you only need a small amount of hydrogen, which is the most thing in the universe. Julio Friedman, chief scientist at Carbon Direct and former chief energy technologist at Lawrence Livermore, told CNN, "There is hydrogen in the water. So the material that generates this energy is pretty much unlimited and it's clean." Why was today's announcement important? This is the first time that scientists have succeeded in producing this, rather than collapsing as previous experiments did. Although there are many steps ahead for this to become commercially viable, it is necessary for scientists to prove that they can produce more energy than they started with. Otherwise, it would not make sense to develop it. This is very important because from an energy perspective, it can't be an energy source if you're not getting more energy than you're consuming, Friedman told CNN. He added, "The previous discoveries were important, but it is not the same thing as generating energy that could one day be used on a larger scale." What are the next steps? Scientists and experts now need to figure out how to produce more energy from nuclear fusion on a much larger scale. At the same time, they need to figure out how to ultimately reduce the cost of nuclear fusion so that it can be used commercially. Scientists will also need to harvest the energy from fusion and transfer it to the power grid as electricity. It will take years, perhaps decades, before fusion can produce unlimited amounts of clean energy, and scientists are in a race against time to combat climate change.